Okay, let's continue on, and our next problem is going to be number 20, which we're integrating from 1 to 4, x cubed minus 2x to the 6 all over x to the 4th dx. So the first thing I'm going to do is separate these so that it'll be easier to integrate. So x cubed over x to the 4th is 1 over x, or x to the negative 1 power. And then we have a minus 2, x to the 6 over x to the 4th is x squared. And now we can integrate. The integral of 1 over x, that's one that you want to remember. This one is the natural log of x. That's in your formula sheet. So this one will be the natural log of x, actually the absolute value. And then when we integrate here, that's going to be minus 2x cubed over 3. And we're going to take that from 1 to 4. So let's plug in. First off, I'll plug in a 4. So I'll have the natural log of 4. Since 4 is positive, I don't need to write the absolute value anymore. And then plug 4 in here, which is going to be minus 2 times 4 cubed over 3, and then minus, and then I'll plug in my 1. That's going to be the natural log of 1 minus 2 times 1 cubed over 3. And let's see what we get. This will get me the natural log of 4 minus, just use your calculator here, this is getting me 128 over 3, minus, the natural log of 1 is just a 0, and then minus 2/3, which will give us the natural log of 4 minus 42. And there's our solution. All right. The next problem we're going to take a look at is going to be number 22. So let's take a look at number 22. On our sheet, which is our integral from 1 over the square root of 3 up to 1 of 2 over 1 plus x squared dx. This is one that we're going to need to look at our formula sheet. And that formula sheet is going to be given to you for any final exam that you would be taking, so you don't have to have this one memorized. Just look it up. If I looked for 1 over 1 plus x squared, that integral is the inverse tangent. This has a 2 on it, so my integral is just going to be 2 times the inverse tangent of x from 1 over root 3 to 1. And then we'll just plug in. So when we plug in first our 1, I have 2. The inverse tangent of 1, and then minus my 2 times the inverse tangent of 1 over root 3. And let's see what we have. 2 times, what angle has a tangent of 1? Well, that would be pi over 4, because the pi over 4 is root 2 over 2, root 2 over 2. And so that tangent would be a 1. So the inverse tangent of 1 is going to be pi over 4 minus 2 times, and what angle has a tangent of 1 over square root of 3? Well, that one is going to be pi over 6, because the ordered pair is root 3 over 2, 1/2. And so when you find that tangent, the y over the x, that's when you're going to get 1 over root 3 or root 3 over 3. So 2 times this one is going to be pi over 6. And let's see what we've got. We can cancel a little bit. That's going to be pi over 2 minus, and 2 into 6 is 3. This will be pi over 3. We can get a common denominator of 6, which will be 3 pi over 6 minus, common denominator of 6 here would be 2 pi over 6. And that final answer will be pi over 6. Pi over 6. The last problem we're going to take a look at will be number 28. So look up number 28. Let's see, this one's going from pi over 6 to pi over 4. And this one is the cosecant x times cotangent of x dx. Alright, this might be one that we would like to take a look at our formulas as well. I mean, if I think of my integral being cosecant, well, the derivative of cosecant is going to be negative, right? Cosecant cotangent. So I definitely will want to put a negative on this one to make the signs work out right. And that's our integral from pi over 6 to pi over 4. Now let's remember what cosecant is. Cosecant is 1 over sine. So what I really have here is negative 1 over the sine of x. And now I can plug in my angles. Start with pi over 4, so I've got negative 1 over. Well, the sine of pi over 4 is root 2 over 2. And then I have minus, and then negative 1 over the sine of pi over 6. And the sine of pi over 6 is 1/2. Alright, let's take those reciprocals. So this will be negative 2 over the square root of 2. This will end up being a plus. And then this reciprocal is going to be a 2. I'm going to go ahead and rationalize that denominator, which will give me negative 2 square root of 2 all over 2 plus my 2. And this does reduce. And so my final answer will be negative square root of 2 plus 2 for this integral.